In this video, we're going to discuss quadratic relations. The quadratic relation has an equation in the form of y is equals to ax squared plus bx plus c, where a, b, and c are real numbers and a must not equal to 0. So when you're going to graph a quadratic relation, it forms a parabola, which is a huge U shape and symmetrical. So this is what a parabola looks like. So there is a line that divides the parabola into in symmetric way. So that line is called the axis of symmetry. So this point, when it is located at the most bottom part, it is called the vertex or the minimum point. It is located a minimum point is located at the most lowest point, while the maximum point is on the highest point of the parabola. Now let us proceed to the how can you use finite differences to determine a relation is linear or quadratic. So if the equation has the value of only 1 square root of x, that is a linear. But if has a squared, that is automatically a quadratic relation. But let us prove that. So we are going to copy and complete the table for each linear relation. Calculate the y values, then calculate the first differences we're subtracting consecutive y values. So let's have b. Y is equal to negative 6x plus 2. So all you have to do is to substitute the value of x. So we have y is equals to negative 6 times 0, since our x is 0 plus 2. So we follow this equation from the given linear equation above. So we have 0 plus 2. Or it is equals to 2. Therefore, our value of y when x is 0 is 2. X we have 1, so we have y is equals to negative 6 times 1 plus 2. So we have negative 6 plus 2. The answer is negative 4. How about the 4x is equals to negative 2? Yeah. Answer is negative 10. So we already have the values of y. So in order to get the first differences, we're just going to subtract the y values. So the first differences, the differences are all equal. So when you're going to subtract the current y values to the previous ones, the result is negative 6 and so on. So when you are going to have a linear relation, in the first differences must be equal. Now let us proceed to the quadratic relations. So we have y is equals to x squared minus 4. So we already have the values of x. Then following this equation, we are going to substitute the value of x to compute the value of y. We have 1 as our value of x. So we substitute it. Y is equals to 1 squared minus 4 based on the given quadratic of quadratic equation. So 1 squared is 1 minus 4 or is equals to negative 3. Okay, we have negative 3. So following our steps, we can now get the values of y when 2 is our value of x. And it is equal to 0. Now we are going to compute the first differences. So I completed the first differences. So the third one is equals to 1. And then we have 0 minus negative 3. That 3, the answer is positive 3. So comparing the two differences, a linear has the same differences while the quadratic has random. Almost the same, but the it is passed in form of positive. I mean the sign is indifferent. So we're going to compute the second differences for the quadratic expression. Now for the second differences of the quadratic expression, a relation. The second differences as already the equal values are the same values. So we can conclude that a linear relation as in the first differences, they have the same values, while in quadratic relation, it took us to the second differences before it has the same value of differences. So if in the first differences they already have the same values, automatically that relation is in a form of linear relation. But if it has to the second differences until it got the same value, so therefore it is in a form of quadratic relation. So by using the table and the first differences or the differences, we can identify what kind of relation is the given equation. So next is to practice. We have number 1. The table shows the path of a ball where x is the horizontal distance in meters and y ah is the height in meters above the ground. So let us sketch a graph of the quadratic relation. So I've already done sketching the graph for this table. Okay, we have 0 and then 1. We have for x 1, the h is 8 and so on. So until 8 where the height is at 1 meter. Then describe letter B, describe the flight path of the ball. So the flight path of the ball forms a parabola and the symmetric axis of symmetric and the vertex is found here. The most were at the middle part and our axis of symmetry is also a line of the vertex. So this is the axis of symmetry. Our point here is the vertex.
So our vertex is the maximum height, maximum point. So in letter C, our maximum height is at 17 meters. Now letter D, verify that h is equals to negative x squared plus 8x plus 1 can be used to model the flight path of the ball. So let's going to substitute the value. So we have h is equals to 1 and then our x is equals to 0. So we have 0. 1 is equals to 1. Next we have h is 1, 8, and then we have our values of x is 1. We have negative 1 plus 9, 8 plus 1, negative 1. 8 is equals to 8. Okay. Next we have 2, 13. So 13 is equals to negative 2 squared plus 8 times 2 plus 1 was 4 plus 16 plus 1. We have negative 4 plus 17. The answer is 13. So this can be a model to represent this graph, but take note it has negative. So according to the definition, a quadratic relation is a relation whose equation is in the form of ax squared plus bx plus c, where a, b, and c are real numbers and a must not be equal to 0. So it's okay. It is only negative man. Okay. This can be h is equals to negative x squared plus 8x plus 1 is absolutely can be a model of this graph.